Hello, everyone. This is Dr. White, and I am going to look at the assignment that I gave on October 19th. I understand that there were some questions. Normally, we would use the calculator, we would use cosine and sine law to solve this problem. But today, we're going to use the tool that we've been using, OnShape. And here we have a bracket, and this problem, we actually have three problems in one. This problem asks us to find the resultant force between forces one and two. And the next part, we're going to resolve F1 into components along the U and V axes. So, what does that mean? That means that F1 now becomes our resultant force, and then U and V will be our component forces. And after that, we're going to resolve F2 into components along the UMV axes. And same thing, F2 will be our resultant force and UMV will be the component forces. So I'm going to probably do this in different videos. For the first problem, I first want to make sure that we understand what we've been given. So let me just zoom. This is what we've been given. We see F2 is 150 pounds, F1 is 200 pounds, and then we have U, which is along the horizontal. We don't have a vertical, but we know that it will be there. It's going to be perpendicular to our horizontal force, which is U. And we've been given, what is this, 105 degrees. So 45 degrees clockwise from the U axis to F1, and then clockwise from F2 to V is 30 degrees, and then from V to U we have another 30 degrees. So I'm going to just sketch out right over here what we have. So I'm going to go ahead and draw. Let me draw my horizontal first. That's U. And I'm only going to draw what's been given in the picture. Let's see how this works out. I have V and then F2. So I'm going to sketch in my dimensions. So from, you see that this line is black. That means that it is at a fixed point. At least one of its points is fixed to our our center, our origin. And we have 30 degrees here. That's not 30 degrees. Let me delete that. From here to there, from there to there, let's try that again. That's going to be 30 degrees. And then from here to here, that's going to be another 30 degrees. And then you see that these lines are turning black. And then from here to here, we have 45 degrees. And those lines are black because there is some reference that we can identify with. This is F2. And then this is going to be 150 pounds. This one is going to be 200 pounds. Okay. So when we look at our, I'm going to move these in some. Will it let me? Okay, I can move those in some. So what I want to do is I want to find the diagonal between these two forces. And the first thing that we have to do is we have to make sure that we connect these components. Now, even though it's shaded, these two forces we know must be parallel to each other. And these two forces must be parallel to each other. So when I make them parallel, I can see that I have this additional point right here. From this point to my origin, that's going to be my resultant force. And this problem asks us to determine the magnitude of the resultant force and its direction, the angle measured clockwise from the U axis. So I'm just going to grab my dimension tool here, and I'll bring it out here. So it's dimensioned at 216.72 millimeters. And then this is my U-axis, and then counterclockwise from the U-axis to here, that's going to give me 3.05 degrees. So that was number one. If there are any questions about that, please let me know. I will try to let me, I think I'm going to just create another sketch. So create a part studio, and I'm still going to use the same dimensions, but this time I'm going to resolve F1. Hopefully. Actually, I'm going to do that in another video because I need to run to a meeting. So if there are any questions about part one, please let me know.